All right, so what we have here is lesson 3-6, factor and solve. So you already know how to factor. This will give you some more practice with that. What we're adding today is the solve part, and I think you will be pleasantly surprised that it is not that bad. Okay, so remember, let's kind of go back over factoring a little bit. The very first thing you have to always check for is, does it have a GCF? Make your eyes scan across the equation or the expression to see if it has a GCF, and then you factor. Okay, here's the new part. All you do is you set each of your factors, okay, equal to 0, and then you solve, okay? Okay, and you'll see what I'm talking about in just a second. So, example 1, my eyes have already gone across this thing and looked. Does it have a GCF? In other words, can they all divide by the same number? Yes, 2 and 2 and 24 are all even numbers. They can all divide by 2. So we're not going to forget our little 2 over here. We've got to always write the GCF out to the side. When you divide, you get x squared plus x minus 12 equals 0. Now, we look in here and we see, can this trinomial right here factor? And I'm not going to bother to use grouping to do this because it doesn't start with a number here. I taught you if it starts with a number here, use grouping. If it doesn't have a number here, if your A is 1, because there's really like an invisible 1 here, then all you do is say what multiplies that adds, okay? And then you slap your answers down here, okay? So we need to ask ourselves, what are the multiples of 12? 1 times 12, if you do it very methodical, 1, 2, 3, 4, 5, like that, you won't miss any. 2 times 6, 3 times 4, and then 4, if I keep going, 4 times 3, but I already have that. So that tells me I got them all. I got all my factors. Okay, now this is a negative 12. That means the signs are going to be different because we're actually trying not to find a 12. We're trying to actually find a negative 12. Okay. So since the signs are going to be different, that means I'm going to subtract. So you can kind of use that as a sign that says, hey, I'm going to subtract, not really add the numbers. Which pair of these subtracts to make a 1? Well, 3 and 4 do. They're 1 apart, aren't they? So the largest number out of 3 and 4 gets this sign right here. Okay, out of 3 and 4, you just put them down here. As I said a minute ago, you just slap them down there. Okay. Which one of these numbers is largest, 4 or 3? Well, 4 is largest, so he gets that sign. Since the signs have to be different, that means 3 is a negative. So if the directions had said factor, we would have been done. We would have just stopped right there. But the directions say to solve. Okay, so we have to set, that's what the directions a minute ago were, to set each binomial factor up, equal to 0. Technically, you want to set each factor equal to 0. So 2 equals 0. X minus 3 equals 0. X plus 4 equals 0. Now, does 2 equal 0? Not in my world, it doesn't. Okay, so that's just kind of thrown out. Okay, here I'm going to actually solve for x, and that's super easy. Some of you don't even have to do this step right here that I did right there. You just know x is equal to 3, because 3 minus 3 would be 0, right? What is x so that it equals 0? 3 minus 3 equals 0. Here, subtract 4, so it's the opposite sign, isn't it? Okay, and x equals negative 4. Okay, so I think probably in Delta Math, you're going to probably write a 3 and then type a comma, and then it'll give you another box. You'll have a box, you'll start typing a 3. When you type that comma, another box will pop up, and you'll use a negative 4. Don't type in the x equal, okay? I think that was the way Delta Math worked. All right. So moving along here. Ideally, what you would do is go back and check these, but you're not really going to have any extraneous solutions here. I don't know if y'all remember back when we did the absolute value problems that were like this. That was what the graph looked like. These were absolute value problems. Sometimes you had an x that didn't work out when you put it back in, and that was called an extraneous solution. Okay, so next problem. Okay, when I scan across here, I see, oh, that has a GCF. A 3 and a 33 and a 90 will all divide by what? They'll all divide by 3. It can't be any bigger than that smallest number right there, you know? Okay, so when we do that, we get x squared. 33 divided by 3 is 11, and 90 divided by 3 is 30. Now, I'm a little bit excited here because I see both pluses, and that's going to make the factoring a tad bit easier on us. So, since it doesn't start with a number here, I don't have to do grouping. I can simply say what multiplies to 30 that adds to 6. So I come over here, 1 times 30, 2 times 15, 3 times 10, 4, no, 5, yeah, anything that has a 0 ends in a 0 or a 5 divides by 5, so 5 times 6. Then I'm at 6, but I already have the 6 there, so that means I got them all. I got all of them, okay? Okay, who's going to make an 11? I think a lot of you already see it. It's a 5 and a 6. Everything's positive, all nice and wonderful for us. 3 equals 0. X plus 5 equals 0. X plus 6 equals 0. So 3 doesn't equal 0. We get to mark him out. X equals -5. X equals -6. Okay, so some of y'all can just say, oh, it's not a positive 6, it's going to be a -6. A -6 plus 6 is going to be 0. A -5 plus a 5 is going to be 0. Okay, so in Delta Math, you're going to type a -5 and then a -6. I think you could type a -6 first and then a -5 if you ended up getting these switched, which is fine. Okay. All right. So now, down here, it looks a little weird. It's not ending in a 0, is it? We've got to bump him back over here so that we have a trinomial, a quadratic equals 0. So I have -12x squared plus 44x minus 24, because I'm going to subtract 24 from both sides, equals 0. But you got to be careful. Make sure they're in the right order. The x squared and then the x term and then the constant. You can't mix these two guys together. They're not like terms, so you have to be careful. Watch what you're doing, okay? So now I have a -12, a 44, and a -24. I notice a couple of things. They're all even numbers, so they can at least divide by 2. And in a minute, when I look at that, I'm going to see if they can divide by anything bigger. I also notice this starts with a negative. So it's best to pull out that negative as part of your GCF. You don't ever want the inside of your trinomial, you know, this to start off with a negative. That just complicates things. You want that negative out here. So that's why your GCF right here needs to be a negative, okay? So if your leading term is a negative, I would recommend just to go ahead and make your GCF a negative. Okay, so 12, 44, and 24. When I first looked at it, I was like, ooh, maybe they both divide by 12, because 12 and 24 do, but then 44 doesn't divide by 12. It would have to be a 48. So it's not going to be a 12, so it's going to be a little bit less than that. It's going to be an 8. No. It's going to be a 6. These divide by 6, but 44 doesn't divide by 6. If it were 42, it would divide by 6. So it's going to be a little bit less than that. So 4. Yes, they'll divide by 4. Remember, it's greatest common factor. So 2 wasn't big enough when we first were thinking a minute ago. 2 was not big enough. So it's a -4. They all don't have an x. So not an x. When we divide, we get a positive 3 right here, and then x squared. We get a negative 11x, and we get a positive 6. Now, what I always look for is, check this again, make sure they won't all divide by something again. If they do, that means you didn't make your original GCF big enough. You don't want there to be a GCF inside here. What I'm noticing, and maybe you're noticing too, is it starts out with a number. So we're going to have to do grouping. I can't simply say what multiplies to 6 that adds to negative 11. I have to include this 3 in the figures, in the calculations. Okay, so I need to say 18. What multiplies to 18 that adds to negative 11? So let's come over here. I notice I have a negative here, but this right here is a positive. I can have a positive times a positive. That makes a positive, or a negative times a negative makes a positive. So it looks like since this is a negative, I'm going to have 2 negative numbers. Okay, so this is a review of grouping right here. Okay, we had a GCF and we're having grouping. All right, so 18. 1 times 18, 2 times 9, 3 times 6, 4, 5, 6. Yep, we already got 6, so we're done. Okay, who is going to make a negative 11? Yeah, a 2 and a 9. If I can get them both to be negative, and I can. Now, don't do this. I have some people doing this. Okay, what's wrong with that? X times x is x squared. We need it to be 3x squared. 2 times 9 is 18. We need it to be 6. There's a lot that's wrong with that. So there's one step that you're forgetting. It's the whole grouping process. So we have 3, let me write in a darker color for y'all. So we have 3x squared. Oh, can't get my act together here. 3x squared. In the middle, we put these two. Okay, and it doesn't matter which order. Minus 2x, minus 9x, and then plus 6. Make sure you go all the way back to the original. Okay, not the 18. Now we're going to do grouping. Okay. Let me move this up a little bit. Okay, so what will 3x squared and 2x both divide by? 3 and 2 both don't really divide by anything, but these will both divide by an x. So when I do that, I get 3x. These little x's kind of cancel out here, minus 2. Okay, this is a negative. Remember, when this third term right here is a negative, your GCF has to be a negative. So they'll both divide by 3. So I get negative 3, and I get a positive 3 here, and an x. I get a negative 2 here. Okay, so we're about ready to write our answer. So x minus 3 is one of our binomial factors. And I almost forgot my negative 4. Okay, can't forget poor little negative 4. Okay, and then 3x minus 2 is another binomial factor. Okay, so we have all these equal to 0. We're going to set up all of our factors equal to 0. And then we solve. Okay, negative 4 doesn't equal 0, so get to mark him out. Going to add 3. X is 3. Now this one's a little different. We're just going to solve. We know how to do this. Don't go into panic mode. Add 2. Divide by 3. X equals 2/3. Okay, so in Delta Math, you're going to type a 2/3, then a comma, then another box will come up, and then a 3. Or you're going to type a 3, comma, another box will come up, 2-3. Don't put decimal numbers in there. Don't put 0.6. Don't do that. Okay. Let's see if there's another one. If not, I got something else. Yeah, there's another one. Okay. So you've got to have everything on one side of the equal sign, okay? Minus 98, 2x squared minus 98 equals 0. Let me use blue or purple. Those are better. Okay, they'll both divide by 2. So I get x squared minus 49. We haven't gone over difference of two squares. Difference of two squares. When you have two terms, that's the 2, and it's subtract, it has to be subtract, two terms that are subtract, and they are both something that you can take the square root of, okay? Then it's super easy to factor. You take the square root of both sides, and the square root of x squared is x, the square root of 49 is 7. And one's a plus and one's a minus. Okay? Super easy to factor those. I'll show you some more examples in just a minute. Okay, so 2 equals 0. Nope. X plus 7 equals 0. X minus 7 equals 0. So here, x is negative 7. It's the opposite sign. X is 7. Okay. Here, they'll all divide by 3. We're having a lot of GCFs today. That's good for us. X squared minus 8x plus 16. 48 divided by 3. 3 times 16 is one of those you need to kind of get in your memory. It pops up every now and then. Okay, what will multiply to 16? I don't have to do grouping on this, guys, because I don't have a number here. Okay, I can do it the easy way. That adds to negative 8. 1 times 16, 2 times 8, 3, 4, 4 times 4. That's it, right? Well, who's going to make a negative 8? This tells me the signs have to be alike. This tells me what they both have to be. They both have to be negative. So you're going to have a minus 4 and a minus 4. Okay? So we set them up. 3 equals 0. X minus 4 equals 0. X minus 4 equals 0. 3 doesn't equal 0. X is 4. Don't type it in twice, just once. Okay? Just once into Delta Math. Okay? Okay, this one down here is a good one to work. I need to show you something, so pay attention to this one. It's a tiny bit different. Okay, you notice it starts with a third. That's because all of these can divide by 6, and they can all divide by an x. They all have an x. So you get a 6x out here. You get x squared. The 6's cancel. Minus x. The x's cancel. Minus 6 equals 0. Okay, what's a little bit different about this one is the 6x here. Most of our GCFs have just had a number and not a variable. So I need to show you that really quick here. Okay, so we have to think of, now again, this doesn't start with a number, so we don't have to do grouping. Okay, we don't do grouping. What multiplies to negative 6 that adds to negative 1. Now this is a tricky combination. It can play a trick on your brain. We're trying to make a 6. So 1 times 6 and 2 times 3. We need it to be a 1. Okay? So, it's when it's a 5, it's tricky. Never mind. Well, 2 minus 3 is going to be 1. The signs are going to be different because I have to make a negative. So it's either going to be a negative 2 or a negative 3, right? The largest number gets that sign. Who's largest? 3 is, out of the pair. 3 gets that sign right there. Right there. So we're going to have x plus 2, x minus 3 equals 0. So we say 6x equals 0, x plus 2 equals 0, x minus 3 equals 0. This time we can't mark this out because it has an x in it. In the past we were getting 2 equals 0. We can mark it out. 3 equals 0. We can mark it out. Negative 4 equals 0. We can mark it out. But this time we have an x. So we actually divide by 6. X equals 0. So we're going to have 3 solutions this time. You know, and I didn't talk to you about what a solution was. Probably need to do that. We haven't gotten to graphing quadratics yet, but I'll give you a sneak peek. So it's the opposite sign. The opposite sign. Okay, so you have 3 answers. So in Delta Math, if you get that, 0, comma, -2, comma, and -3. Oops, +3. They'll, boxes will pop up. So be careful. If you have an x here, don't just mark it out and go, oh, it goes away. It doesn't. It's x equals 0. What I was going to show you is what we're graphing is quadratics. Well, right here. Anything that has an x squared, if it starts out with an x squared, if its highest power is an x squared, it's a parabola. Okay? Sometimes those parabolas cross the x-axis. Those are your solutions. That's what we're finding, the places that the parabola crosses the x-axis. This one is not necessarily a parabola. It's a weird one. It crosses the x-axis like in 3 places. Okay, that's what that means. Okay, one other thing I want to show you before we stop is a little shortcut trick. Notice, you know, when we were getting x plus 2, okay, we knew x is -2. If we had x plus 7, we knew x is -7. Easy peasy. You do the opposite sign. X minus 8. X is going to be 8. Okay? If you have this, if you have 4x plus 7 equals 0, if that was one of your binomial factors, you can do this. You can subtract 7, get 4x is -7, divide by 4. X is -7/4. Okay? But there's a pattern here. It's the opposite sign of this, opposite -7, that's a +7, divided by the number in the front of the x, the coefficient. Okay, so if you have 3x minus 2, the opposite of -2 is +2 divided by 3. Okay, if you had 5x plus 3, the opposite of +3 is -3 divided by 5. It's just a little pattern. And if you still want to do this way, that's fine. That might be, if you're kind of weak at math, you might want to do that. Those of you that are a little stronger at math that can see patterns, you could probably do it this way. You can kind of get that pattern down. Let's do a couple of more. Let's just get fancy. If you have 11x plus 9 equals 0, you know x is going to be the opposite because you're going to subtract 9, right, over here. You know it's going to be the opposite, and then you're going to end up dividing by 11. So the opposite sign, divide by 11. Okay? If you have 2x plus 4, let's do this. I don't think you'll get one like this because it has a GCF in it, but let's just pretend. So you're going to have the opposite of 4 divided by 2, but then that is actually -2. Okay, so watch out for reducing if you need to reduce. Let me do another one. Because once you get the pattern down, you're good. Let's say in one of your binomial factors, let's say you have x plus 2, and then you have, I don't know, 3x plus 7. I don't know if I've done that one. Okay, well, you know here x is going to be the opposite, -2. Here, you're going to say the opposite of +7 is -7 divided by 3. Okay, but remember, you can always do it like this. You can always really solve it using the correct steps. Okay, got the same thing. Whoa, I didn't. Oh, because I had the signs wrong. But you get my point, okay, hopefully. So that's just some pointers. Okay.